Hello, welcome to this case solve. Today I'm looking at a case from the World Championships in 2024 called IsometriChaos, created by Klinsmann. And this was, I really like this case, one I've only come across recently as a relatively new player, so it wasn't around when this was being competed live. I like this case because it's one of those where it's just a very simple idea that then requires or creates a lot of complexity. So the basic idea is we've got this grid which takes the concept of a normal table, rows and columns, rotates it 45 degrees, and that creates all sorts of complexity where we have our, whereas normally at the top of our thing we'd have, A1, B1, C1, those are now going down at a 45-degree angle, and that then creates spaces between the cells which are filled with numbers, and that's all the questions relate to this bit of data here. So yeah, you'd think, how can I make a case out of that? But actually, yeah, really good. I will say a little bit about how this how people got on when they did the live version of this, as best I can work out. And as I'm going to start doing with some of these walkthroughs, because the aim is for me to learn as I teach or walk through it, rather than replicate how this might be done in a live solve. I've done a little bit of the pre-work setting up my data tables, just so you're not wasting time listening to this thinking he could have done this beforehand. So we will still time it, but we're not doing this to try and say, oh, this is how quickly we would have done it, or it could be done. So yeah, hopefully that makes sense. So let's go to our score sheet. Let's start the timer and let's get going. Okay, so I'm assuming you've looked at this case if you're watching this. If not, then not really sure why you'd be watching it. So everything based on this data in the ISO grid. So I'm going to just do a little bit of setup first. I'm going to select the whole range, and I'm going to call this the ISO map. And then what I need to do is I basically need to flatten this data, and I am going to use a number of lambdas throughout this, just to speed things up. So for this first one, I'm going to use the address book lambda based on the ISO map, which is going to give us our kind of contents and our cell references. And I'm going to call these the ISO refs, and I'm going to call these the map refs. And then I'm actually going to select all of that, copy and paste it as values only, so it's not recalculating every time we do anything. And then I'm going to also Control Shift F3 and name these as ranges, and that's going to help me with the first two levels, because all I need now is an X lookup. So I want to, on first given, what is the content of the given cell reference? So I'm going to X lookup the cell reference in my map refs and return my ISO refs, and that should give me my cell references. And we go into our score sheet and paste that. 40 out of 40, good start. Okay, level 2 is basically the opposite. What's the cell reference of the given ISO reference? So this time I'm going to do X lookup on the ISO refs, returning the map refs, and we get those values and we paste that in, and we're on 80 points. So that's good, nice and straightforward to start off with. This is where it starts getting complicated, and for this level I'm not going to use a data table. I'm just going to show my working. I'm just going to move that across. So basically we're given an ISO reference which refers to the value in. We then told a number of steps and we're given a direction, but these are diagonal directions which on the actual grid refer to kind of horizontal directions. So moving up and to the left actually means moving straight up. So what I'm going to do is set up some lookups. I'm going to grab the unique values from the questions, which gives me my 4 arrows. And then basically what we're doing, so when we're going up to the left, we're actually going up. So we need to look for each arrow. We basically need to go, we're actually moving 45 degrees to clockwise. So what I'm going to do is I'm going to say for this one, let's zoom in a bit. So this one where we're going down left, we actually want to go left. So I'm just going to put letters for now. Down right means we're actually going down. This one clockwise will be going up, and this one clockwise forward is going right. And then I've got a lambda, which is called arrow from text, where I can take these inputs and it will give me the actual arrow. So left, down, up, right. So that's some of the prep work we need there. So let's say we want to start with the cell because we're given the ISO ref. So let's X look up the ISO ref in ISO refs and return the map refs. So we're actually in AA6, and then we want to know the actual direction rather than the direction they gave us. So we're going to X look up the arrow they gave us with against this. We'll lock that reference and we'll put it up against our new arrows, and then we're going to do the actual move. So I'll move, so I'm going to use my move on map lambda. Say that as if it's mine, it's not mine. So we start in cell AA6, we move in this direction. We are going to go this many steps, and I don't think this makes a difference, but I'm going to put isomap just in case. And so we move to AA3, which is 3 cells above AA6, which makes sense. And then the last thing we need to do is put this back into our isoref. So we say x lookup the cell in our map refs, returning our isorefs, and we get 7, which matches the example. So we'll just go down, fill that all up, grab our answers, grab our answers, which are those, go to our score sheet and paste those in. It's being a bit slow for some reason. Let me just try refreshing the page, see if that makes any difference. It's kept our answers from before. Has it kept what's on the clipboard? Nope. Let's try again. Did I actually copy it? I did hear a slight ding when I did that, so maybe I just didn't copy it. Okay, it was all correct. Let's go back. So level 4, we're going to start going on to our data tables, which I've pre-set up. So we're given a, is this a cell reference? Yes, this is a cell reference, and we're told to look left and right, but because it's diagonal, it's actually, in this case, diagonally down, and we want to get all the values in that diagonal. So for this, we need to basically find a way to identify diagonals, and the way I do this is I'm going to create a range called diagonal up, so kind of diagonals going that way, like a forward slash, and then diagonal down, which is like a backslash. And to do this, we basically add together the value of the row number and the column number of the cell reference, and then for the other diagonal going the other way, we take one away from the other, and it doesn't actually matter which way we do it. So I'm going to do row number minus column number of that. Doesn't matter as long as we're consistent with all of them. So if I go to the bottom and fill that down, I've then got my values, and I'm going to, again, Control Shift F3 to name my ranges. So I've got diagonal up and diagonal down. So this kind of gives us a unique identifier. So all the ones in this row will have the same diagonal down value, and that allows us to isolate those cells. So we need to, for this, firstly, just double check that is a cell reference they've given us. Yes, they've given a cell reference. So the cell is what's in B1, so that's fine. And then what we need to do is we need to work out, well, which diagonal is that in itself. So I'm going to do X lookup of the cell in the map refs and return the diagonal up, and it's in diagonal 32, and then do the same thing for the other diagonal. So X lookup the Z6 in the map refs and return diagonal down, and it's in -20. Okay, so now let's get all the other values in those. So I'm going to use filter, and just to show this is working for us, I'm going to do filter the map refs where diagonal up equals the same diagonal up of our cell. So we get Z6 is in there, but we also get Y7. So if we think about that, if Z6 is here, then Y7 is one left, one down. So that's giving us a diagonal going in that direction. So that is the correct references, but we don't actually want the references. We want to know the values. So we want the isorefs. So those are the values that are in there. And if I just sum that up, we get 86. So let's do the same thing. Let's copy that formula into the next bar, and we'll change that to diagonal down is equal to this reference, and we'll fill that to the right, and we get 130, which matches what we're expecting. So we just need to be able to tell the difference whether we're looking at this value or this value. So are we going up or down through the isolated cell? So let's grab one of each of the possible inputs. And so in this case, we're looking left and right, and we want 130. So this needs to equal that. And this will therefore equal the other one. And then our data table, we can just say X lookup the arrows in this set and return whatever it is here. And we'll copy those over to our score sheet for level 4, and we get it all right. So that's good. Carry on. So level 5, okay, similar sort of thing. This time we're now going to be given a isoref, so the value in here, but because we're given those, we then need to look at the 2 rows to the left and to the right of it. So let's start by finding out what the cell reference is. So we want to say X lookup the value up in B1 in our IsoRefs and return our map refs. And then actually here we can probably just grab the working from before. So let's grab this. Hopefully I've done it in the exact same cell location. Yep, so we've got our diagonals up and down. Let's just move this slightly. So we want to firstly try and grab, we're going to filter the diagonal. Nope, we want to filter. I'll do map refs first just to check this is working. So map refs where the diagonal up equals this value here, and that gives me everything that includes W10, X9, but I don't actually want those. I actually want the two either side of it. So what I'm going to do is I'm going to copy this to another cell, and then what I'm going to say is I want to take the value in here, -1 so we get the next diagonal along, and in this one I'm going to add 1 so we get the next one to the other side. So I'm now getting the references for the two columns or the two diagonals to the kind of left or above and below and to the right of the row that we're looking at. So we're now getting these green cells, but we don't actually want the references, the cell references, we want the value. So we change that to IsoRefs. And if I sum those and fill that to the right, we would get the two of them. And actually if I add those up, this is 210. So this is going to be the correct answer for this particular example. We need to do this in case this arrow was the other way. So again, let's just move that over to the side. So we're now going to do the same thing. I'm going to grab these two, paste them. And what do we need to change? We want to get the IsoRefs where the diagonal down equals that, and the diagonal down equals that, again offset by 1 for each case. And so if it had been that we were going up and down, we'd actually have 2, 4, 6. So let's go back to our case, grab one of each example. Let's paste this in here. So we're going up and down, so we want those first. So we're going to say that plus that. And therefore, if it's the other one, it's going to be that plus that. And we'll do a similar thing as we did before. We'll X look up the arrow in this range, returning this range. And we'll copy those over to our score sheets for level 5. And we get 160, and we're good to go. Okay, level 6. I think this is actually slightly easier than level 5, but that might be because I've got a lambda, or I've found a lambda that does this very effectively. So we've got a similar thing where we're given the IsoRef. So let's just grab the bit of work that converts that into a cell reference. And then I'm going to use the closest on map lambda to say I want to look into the ISO map, starting in this cell, going for this many steps, and I don't want to be able to go diagonally. And that gives me everything. So we can see from D4, the first row is 1769, or the first ring 1769, and so on. And we just want these values in the first column. So we'll say take that on the first column. And we can actually, even though there are some letters in there, if we just sum that, it will ignore those letters or the texts. So we actually just can point to that and we get our answers. And we go to level 7. Level 6, and that's all correct, so that's good. So yeah, that was much quicker than level 5. And then level 7 is the most difficult, where we're given an IsoRef and we're basically asked to kind of imagine we're splitting the grid into 4 quadrants, and we need to grab either the above and below or the left and right. So we're going to need to work out each of these quadrants. So I'm going to grab the starting work from level 5 because we need to know the diagonal of the or the diagonals associated with that cell. And then what we're going to do, going to delete that because I don't think I need it. Let's move out slightly, move that to the side. So what I'm going to do is I'm going to do some filter. So I'm going to filter let's start with the map references again, just so we can see. Actually, no, let's go with the IsoRefs. And what do I want to filter? I want to filter 2 conditions. So I'm going to say where the diagonal going up is let's say greater than this, and the diagonal going down is greater than this. Okay, and that's going to give me a section of this, and if we look we can see D5, D6, E5. So D5, D6, that's in this lower section, so this below section. So let's label this the below section. Okay, and then let's keep going and doing this for 4 different ranges. So I'm just going to copy this 4 times. I'm sure there's a quicker way of doing this, but I'm not going to worry about it now. So if we change this, so this time instead of going greater than each time, let's change each of these to less than, and I think this is going to give us the area above. So we get A1, A2, A1, A2, that's this section above. So that's the above section. And now if we change one of these to less than, this time we get A5, A6, which is this kind of left-hand section. So in this last one, if I change the second value to less than, we get D1, D2, which is all of this stuff over here. So that is the right section. Okay, and let's just sum up each of those sections. And we've got 2 possible things we might be asked for. So either diagonal kind of up or down. Those are our 2 possibilities, and when it's going left and right, it's actually asking us, in this example, for the top and bottom. So that is going to be sum of that plus that, which gives us 2532, which is the example. So when it's the other way, it's going to be this plus that. And if I X lookup based on the arrow, looking up in this range, returning from this range, and we get 1 error. So I think that's because we get a 0 because it's so high. So what we're going to do is we're going to put an if error on here, 0, and then we'll fill that to the right. And that should remove all of our errors. So we'll copy those over to level 7. All good. So we've got all the main questions correct. We've taken just over 15 minutes. So let's move on to the bonuses. And let's start. So the bonuses, what's the cell reference of the only empty cell within the ISO grid? So when I first did this, I just happened to have spotted when I was doing some work that there is an empty cell down here. And you could just then go, well, that's K33. But if you were looking for something a bit more systematic in case you don't want to look through it, in case this was really big, what I would probably suggest is I'm going to select the ISO map, I'm going to apply some conditional formatting, and I want to find anything that is equal to 0, which will also cover if there's nothing in it. And to make it really stand out, I'm going to fill that with a very dark red. And what we find, obviously everything around the edge goes red, but then we've got that one cell there we can see is red, K33. I did kind of wonder what you would do if, like, I've seen cases where the data map is massive and you couldn't possibly look through it even visually. And I think you would have to do something, well, I tried something where you basically work out the maximum and minimum diagonals and then filter to everything within that and then search for those that are 0. Because if you just try to use the address map, because you've got all these empty cells outside of the range, you've got to have some way of identifying what's actually within range of those that you do have. Oh, didn't mean to press that. How many 7s are in the yellow cell? So this we can just say sum of the ISO map equaling 7, which gives us 80. Let's just quickly copy those over to the score sheet in case we make any mistakes as we go along. We'll come back to those in a minute. What's the sum of the yellow cells? So we can actually just say sum ISO map, because it will give us everything that has a number and ignore the text. And then it says removing all the letters and transforming it. So K22 becomes 22. So this is fairly similar to the last one before. I'm just going to sum, I'm going to use extract numbers on my ISO map. And we get 2 more answers. Let's just copy those over while we then do level 5 or bonus 5, which takes the longest. So we got the first 2 correct, so that's good. And yep, those are both correct. So let's just go to the final one. Bonus 5, based on level 5 rules and all ISO ref and direction combinations, what's the max possible sum for a particular ISO ref? So if we go to level 5, we'll make a copy just so we don't upset our original work. So instead of looking at the specific questions, we need to try every single ISO ref option. So let's get our ISO refs, and then we want to filter just to the ones where it's text. And we get all of those. I'm going to copy those into my data table. I'm going to remove the data table for now. And then what I need to do is I'm going to point to this cell, but this one needs to be changed as well. So let's copy those as values only. And then in our data table, Alt D2, our input cell is going to be B1. And we get some calculation errors, which I think is going to cause an issue when we try and look for a max. So let's just change that to if error 0. and do that again, and then let's just search for the max of that, which gives us 285. So let's just store that statically for a moment. So that's when it's, let's put it next to the up and down arrow because that's what it was. Let's now change the up and down to a left and right in case there was a better combination going the other way. And it says 285, but I don't actually believe that because I'm sure it's different. So I'm just going to refresh the calculations, and yep, we get 278, which is less than 285. So our answer should be 285. And we'll go to our score sheet. We'll put in 285, and that should come through as correct. So we'll stop solving early. It gives us 19 minutes, all the points going through with a little bit of explanation as we go through, but also some prep work done. So so the first time I tried this, I think from memory, I got somewhere in the 800s, maybe 900, but then I was playing on the platform here where I had the individual feedback on, so I knew if I got something wrong. So that does obviously help. If I look at the competition rankings, now it says this was this, according to the wiki page, this was the semi-finals in 2024. And the semi-finals, there's two, so I don't know if this means they all played the same case or they did different cases. I'm not sure how it works. I think if they're taking place at different times, then they're doing different cases, because otherwise you could see. So either the best score was 1030 or the best score was 610. And obviously this is the semi-finals where I think there's elimination. So these low scores don't mean people couldn't get anything. It means they got eliminated because of the way it works, and they might have been trying to get bonuses first, and therefore. So I don't know. I suspect this seems more realistic, that somebody on the live case got up to 1,000 points on the first time of seeing it, rather than it being this 610. Having said that, I'm doing this a couple of years later where there's more common usage of lambdas, I'm assuming, so maybe that was okay. But yeah, and not really anything new to say. Obviously there's plenty of other walkthroughs already, so I'm not covering anything new that hasn't been seen before. But like I said, I really enjoyed this case on the basis that it is a very simple concept, very simple data set, but just with one interesting twist, which is the rotation, and that makes it very difficult to deal with. I think what helped with me with this was that understanding about diagonals, which I came across. There was a chess related case where understanding how bishops move, you need to get your head around diagonals and how to identify a diagonal and kind of quantify it, so you can say, right, what is everything in that diagonal. So yeah, good case, and that's all there is really to it. Hope you enjoyed it. Like I said, I'm doing this mainly for myself, but if you find it helpful, great, and that's all there is to it.